Good evening. Now we will go with section 5, that is limit state method given in IS 456. And we have this as plain and reinforced concrete code of practice. Now page number 67. So we have this structural design limit state method. So we cannot go in detail in the class. So now you can go very clearly with this. So now you can see what is limit state. So they have mentioned in the method of design based on limit state concept, the structure shall be designed to withstand all loads liable to act on it throughout its life. It shall also satisfy the serviceability requirements. Means loads means generally we are considering collapse loads. And therefore that limit state is known as limit state of collapse. So we are going to study two mainly. One is limit state of collapse and second is limit state of serviceability, such as limitations on deflection and cracking. In serviceability, we deal with deflection and cracking. The acceptable limit for the safety and serviceability requirement. So acceptable limit. Now this you have to keep in mind. The acceptable limit for safety and serviceability requirement before failure occurs is called limit state. Both, that is safety and serviceability. The aim to design is to achieve acceptable probabilities that the structure will not become unfit for the use for which it is intended. That is, that it will not reach a limit state. Means the loads on coming on it should be less than resistance and deflection occurs should be less than the allowable deflection. Now all the relevant limit states shall be designed. I already mentioned we are generally with two: limit state of collapse and limit state of serviceability. Now they have mentioned in general, the structure shall be designed on the basis of the most critical limit state and checked for other limit state. So we are going to design it for limit state of collapse and we are going to check it for limit state of serviceability. So two main limit state you have to keep in mind: limit state of collapse, limit state of collapse, and second, limit state of serviceability. Limit state of serviceability. Means we are going to design for this and we are going to check for serviceability. So limit state of collapse I already mentioned, and they have mentioned over here the limit state of collapse of the structure or part of the structure could be assessed from rupture of one of more critical sections and from buckling due to elastic or plastic instability or overturning. So this is most important for us. So the resistance to bending, shear, torsion, and axial loads at every section, because bending and shear we have beams, torsion also we are considering in slabs, bending and shear again we are in slab also, and axial we are going to be in columns. In columns we have both axial as well as bending. So at every section shall not be less than, keep in mind, resistance to bending means this bending, shear, torsion and axial, these are due to loads. and resistance is property of the materials. And this resistance should be always greater than bending, shear, torsion, and axial load, which are due to external loads. So shall not be less than, means resistance is not less than appropriate value at that section produced by the probable most unfavorable combination of loads on the structure using the appropriate partial safety factors. Means our resistance should be always greater than loads. Greater than loads. That we have to keep in mind. Then we have second, I already mentioned, limit state of serviceability. And here we are mainly interested with deflection. Cracking also we are not going to consider. And these are given in clause number 23.2, which we will see in this, which is given on page 37. So the deflection of a structure or there or part thereof shall not adversely affect the appearance or efficiency of the structure or finishes or partitions. The deflection generally be limited to the following. So two criteria are given. One that is given for from the as cast level of the supports of floors, roofs, and all other horizontal members should not normally exceed span by 250. Means all floors, roofs, and all other horizontal members should not normally exceed span by 250. And then if we have erection of partitions and application of finishes should not exceed span by 350. So here we have for partitions and finishes span by 350, and for roofs and other horizontal members we have span by 250. So here span by 350 and span by 250. Then we have page number 67, characteristics and design values and partial safety factors. So you can see this, the characteristic strength means the value of the strength of the material below which not more than 5% of the test results are expected. So keep in mind, if you have 100 values of the test of materials, and if you have these values from higher to lower, then we have to consider fifth value as characteristic strength. Means below which we should have. So here you can see not more than 5% of the test visits are expected to fall. So this you can write fifth or you can write sixth. So sixth value better I can say, and below which we have only 5 values and above which we have 95 values. So only 5% are below your characteristic strength. And if you will go to loads, you can see the term characteristic load means that values of load which has a 95% probability. What does it mean? Again, you have 100 values of loads. And in the same way, we have values that is from higher to lower. Then we have fifth value from higher. Try to understand difference between the two. Load we are going to consider maximum. Only 5% are greater than characteristic value. 5% are greater than characteristic load. 95 are below. And here 95% are greater than characteristic strength of material. 95% are greater than characteristic strength. So try to understand the difference. That is characteristic strength and characteristic loads. Then we have page number 68, design values. So we have design strength of material is FD, that is design strength, where F is characteristic strength upon gamma M, that is partial safety factor. Partial, why we are saying we are using two safety factor. One is for concrete, another is for steel. And therefore, these safety factors are known as partial safety factor. So for design strength, we are going to divide by partial safety factor to characteristic strength. And in case of design loads, we are going to multiply the characteristic load by partial safety factor. Means we are going to increase load, and we are going to decrease the strength of material. Means we are using partially safety factor for materials also and for loads also. Decrease the strength of materials. So we have, this will be gamma F and gamma M. Gamma F we have partial safety factor for loads, and gamma M we have partial safety factor for materials. Then we have partial safety factor gamma M for material strength. So we have two values. One is for concrete 1.5 and another is for steel 1.15. Now here they have mentioned gamma M values are already incorporated in the equations and tables given in the standard for limit state design. So they are using 0.87 Fy, means they have used Fy upon gamma M, where gamma M we have 1.15 for steel. Then we have these values. Now for load combination, so you can see for limit state of collapse, we have this value, that is 1.5. Gamma loads, so we have, that is gamma F for loads. Then we have dead load plus wind load. So we are taking dead load 0.9, wind load we have 1.5. So then for serviceability, this is for limit state of collapse, and for limit state of serviceability, values are given over here. We need not require to remember these values. So you can see in last, we have mentioned over here, that is gamma F, partial safety factor for loads. And that are given in table number 18, page number 68. So these are the some part we have related with your clause number section 5, that is for limit state. So now we will stop here only. Thank you.